post the version that is blank. So when you go to today's date in your Google Classroom, there will be a blank copy of this along with the picture of the pineapple and the pizza, because I felt like that was important to your understanding and also makes me smile. So that will be there, the blank copy, and then I will post the video of the explanation. I sadly used U of M colors, but we're just gonna push past that. So, listen please. I plugged in my A plus H first. So this is the one where the A plus H is plugged in. This is the one where just the A is plugged in. And then we've got this H hanging out on the bottom in the denominator all by itself. Keep in mind that when you multiply this out, it'll become A squared plus 2AH plus H squared. Because truly, you are foiling it, right? Like you have A plus H and then another parenthesis A plus H next to it. So make sure that you actually do square it. I'm going to do a bonus step here. I'm also going to distribute. 5A squared plus 10AH plus 5H squared. Then I've got minus 5A squared minus 2. Be careful that you use parentheses around this second part because this whole thing is being subtracted. So we need both parts of it being subtracted. Stuff should cancel. If stuff isn't canceling, oh, I forgot my plus 2. There we go. If stuff is not canceling, then something went awry, right? Like I just noticed, oh, my 2's aren't going to cancel. That's because I forgot the other one. All right, here, an H with an H with an H. So I've got 10A. Instead of 5H squared, what is this going to become? Just 5H. And so this would be my final answer. So again, this plus 2, let me put it down where it really belongs because it looks like an exponent up there. The plus 2 should have been here, and then the minus. And then these were the 2's that canceled. Okay? Good for that one? Okay. Number 2, what can x be for part A? -4, because that would make my denominator 0. So, in interval notation, negative infinity to -4, but I can't include the -4, so I have a parenthesis. In union with -4 up to and including infinity. Boom, done, that's my answer. Bless you. Okay, problems like this. Whenever there's an even root, remember this was a red flag for us that we had to look for a domain because it had to say greater, listening, or equal to 0. Otherwise, we were in imaginary number land, which is not where we would like to live. Let's see. I'm going to have x plus 7 and x minus 5. So when I go to factor it, 7 and -5 multiply to -35, and then they subtract to 2. So we've got critical values of what? What are my critical values? -7 and +5. And then we can pick numbers to plug in. So I'm going to plug in 0, I'm going to plug in 6, and I'm going to plug in -8. When I plug them in, I got that the middle section did not work out to be true, but the outers did. So let me show you what that would look like. 6 plus 7 is 13. So I had 13 times 1. 13 times 1, is that greater than or equal to 0? That checks out, right? So that's how I saw that it worked. So the middle section would not check out. This section should check out as well, that it's a positive value. So I went through and I shaded. Again, these can be closed because it can be equal to 0. The only time you wouldn't be able to have it be equal to 0 is if I change this into a fraction, right? If I put 1 over, then we'd have to have open circles, but there's none of that there, so we don't have to have that. Negative infinity to -7. Union, 5 to infinity. How'd we do on those? Good? Okay. Here we go. Next one is a graph. So you should have a spot on those boards that you can truly grasp.